everyone, Mrs. Syed here. I hope you guys are doing well. I hope the exam went well for you. So far, you guys have been doing pretty good. So I looked at the calendar and it turns out that we only have 5 more classes left. Not school days, but classes. So 5 more cycles. So we are coming to an end, and that's crazy. And this lesson, today's class, is one of the 5. So today we're talking about solutions and concentration. So let's do a little flashback. Who remembers this flow chart from the beginning of the year? We looked at this flow chart when we were classifying matter. And you guys did that fun lab where you had to separate sand, salt, and iron filings. And you came up with the procedure yourselves to do that. And we were looking at this flow chart during that unit, and we're going to be focusing on today's lesson on homogeneous mixtures, which is also known as solutions. So we're kind of coming around full circle, right? We kind of like studied compounds. We studied ionic and covalent compounds. We studied, obviously, elements, the whole periodic table of elements. And now we're kind of zooming in here, okay, to solutions. I also took the slide out. I edited it. I just made it match the theme of this PowerPoint, but it's the same exact slide from the beginning of the year. So you guys kind of already know this. A solution is made up of 2 parts, the solute and the solvent. Okay, so follow my cursor throughout this lesson. So solute is the thing that you are dissolving. Okay, so whatever you're trying to dissolve, maybe salt, sugar, whatever. And solvent is the thing you're dissolving in. So it could be water, for example. Water is a universal solvent because almost, I'm not gonna say everything, but a lot of things dissolve in water. So like I just said, an example is salt water, right? So salt would be the solute, water would be the solvent. Okay, the solvent's usually more than the solute. Solubility refers to how much of that solute is dissolved in a solvent. So how much of that, let's say you're putting salt into water, how much of the salt dissolved? Or if you're putting sugar into tea, how much of that sugar dissolved in the tea? Now, a few different things affect how well something can dissolve, or it can affect the solubility. Number 1 that we can list is temperature, right? For example, we just mentioned tea and sugar. If you put sugar into hot tea, it dissolves a lot quicker. Okay, another factor that affects it is surface area. So sticking with sugar, if I put a sugar cube or just a few little, I don't know, grains of sugar into tea, which will dissolve first? That cube or those few little grains? Okay, so if it has a smaller surface area, it will dissolve quicker. Agitation. An example of that, once again, sticking with sugar and tea, if you put your sugar in your tea, even if it's hot or cold, you stir it, right? So stirring that, causing that agitation, helps it dissolve. So these are the 3 main factors that affect solubility. It affects how well the solute can dissolve in a solvent. There are many different ways to show how well something dissolved, right? That's called concentration. So concentration is a measure of how much solute is dissolved in a specific amount of solvent or solution. So if you want to show exactly, like if you want to give a number of how much something dissolved, there's different ways of doing that. There's different concentrations that you can do to display how much of the solute dissolves in the solvent. So this is a whole chart of different concentrations, okay? There's percent by mass. The formula is right here. There's percent by volume, molarity, molality, and mole fraction, okay? The most common ones and the ones that we are going to study today, actually the most common is molarity, but the two that we're going to study today is molarity and molality, okay? These are the two measures of concentration we're going to learn today, and these are the formulas of it. Okay, so if you need to calculate the molarity of a solution, you do the moles of the solute divided by the liters of solution. And then if you need to calculate the molality, you do the moles of the solute divided by the kilograms of solvent. I hope you guys are enjoying this, right? This is fun. I hope I'm not boring you. We're almost done. We're just going to do 2 example problems and then we're done. All right, here is a molarity example problem. It reads, 100.5 milliliters of solution contains 5.10 grams of glucose. What is the molarity of this solution? The molar mass of glucose is 180.16 grams per mole. All right, so it's set up into 3 steps, and I actually have the steps right on here on the PowerPoint. I'm not going to be using my cute little mini whiteboard today. So step 1, calculate moles. So just like all of the conversion problems that we've done, we're going to start with what's given on the outside. This is a little tricky because we have 3 different pieces of information. Just know that the one that's with grams is what we're going to start with because we've always converted grams to moles. So that's what we're going to start with. That's step 1. You divide the grams by the molar mass of glucose, which is given, and you calculate the moles of glucose, which you just took an exam on, so hopefully you feel confident in doing that. Okay, that's step 1. You're done. Step 2, you're going to convert the volume of water to liters, okay? Because that formula, remember the formula was moles of solute over liters of solution. So you have to make sure it's in liters. The example problem gives us in milliliters. Now, this we also did in the beginning of years, in the beginning of the year, converting between milliliters and liters. So it's just like any other conversion factor. You set up the conversion, and this is what it would be. You write what's given on the outside, which is 100.5 milliliters. And then the conversion that you fill in, for every 1 liter, there's 1,000 milliliters, right? And then our units cancel out like so. So once you do the math, you get 0.1 liter of solution. All right, step 3. We're going to solve for molarity. Yay! All right, so write down your formula, which is moles of solute over liters of solution, and we're just going to plug it right in, okay? Pretty straightforward. We calculated our moles of solute, we calculated our liters of solution, and so now we plug it in. So we're going to plug in this, 0.283, divide by 1.005, and I want to note that molarity has its own unit, which is a capital M. So moles per liter, even though they're not the same unit and you can't see that they cancel out, mole over liter, the unit for it is just capital M. So your answer, plug it into your calculator, and then you're going to label it with an M for your unit. So the final answer is 0.283 moles. The molarity is 0.283. Do not say 0.28. Do not do what I just did. Don't call it moles. The concentration, the molarity of it is 0.283. Okay, molarity is different than moles. I hope you like the animations. I tried to make the answer a little more dramatic than the other animations. I hope you noticed. Now, let's move on to the next one. A molality. So we just did molarity. Now we're doing molality. So I don't know why I'm yelling. Okay, so I think quarantine is getting to me, you guys. All right, molality. Who remembers what the formula for molality is? Insert Edpuzzle question. Okay. A student adds 4.5 grams of sodium chloride to 100 grams of water. Calculate the molality. Very similar. The steps to this is very similar to the steps of molarity. So first you're going to calculate the moles. Then you're going to convert this time. Instead of doing volume, we're doing mass. So you're converting mass to kilograms. And then you just plug it into your formula. So step 1, calculate moles. You do 4.5 grams, what's given, divided by the molar mass, which I gave to you right here. When you do these on your own, you need to figure out the molar mass on your own. And when you do that, you get 0.077 moles of sodium chloride. Step 2, you convert the mass to from grams to kilograms. So just like any other conversion, you set it up, what's given on the outside, the unit desired on top. And remember, for every 1 kilogram, there is 1,000 grams, okay? Just think about it. What's bigger, a kilogram or a gram? If you forget these conversions, if you forget that there is 1,000 grams in a kilogram, you can Google them or look back at your notes. But when you show me your work, I do want to see the conversions. Probably like, oh, Miss Saya is always so crazy about showing work. Sorry, guys. And then last but not least, solve for molality, okay? We write down the formula. We know we solved for the numerator of the formula, which is the moles, and the denominator, which is the kilograms. And then you just plug it in and solve. Look, another dramatic animation. All right, so if you do 0.077 moles divided by 0.1 kilogram, you'll get 0.77 moles per kilogram. You could also label it as a lowercase m, okay? Just like for molarity, it was a uppercase m, so either is fine. And that's it. Now you have another couple practice problems to do on this. So I hope you enjoyed this cycle's lesson on solutions and concentration. All right. Special shout out to those who logged on to my review conference. It was nice to have that little kind of a feeling of a class again. If I do another conference, which I might, I hope to see some more of you log on. And I know some of you are really curious about like whether or not there's going to be a final. I really don't know yet. I promise as soon as I find out, we're going to find out at the same time. They'll probably send an email out to you guys the same time they send an email out to the teachers. So yeah, if there is a final, I'll definitely do like a review conference, but I don't know if there will be. All right, that's it. Have a wonderful day. Go outside. It's nice weather lately. Enjoy the rest of your day.